Hey guys, this is session 10 of AI Engineer where we looked at LLM servers. So the goal was to deploy an open source model endpoint on Fireworks AI, build a RAG application on top of that, and then evaluate it against OpenAI using RAGAS. And we've seen a lot of the OpenAI. So the first thing to do was actually deploy and do a deployment of a hosted LLM. So in this example, we did GPT OSS 2 billion parameters as a dedicated endpoint. I think one of the key things I learned here is the difference between serverless and dedicated. So here we've got more of a dedicated endpoint, whereas serverless is fully, managed quite similar to Lambda functions in AWS and the likes, and serverless is pay per token on shared infrastructure, whereas dedicated gives you kind of reserved capacity, but you're paying per hour regardless of the usage. And so, yeah, an interesting thing to take into consideration when designing your systems. On top of that, we deployed it, and we can take a look at what it looks like to slam it per se and send as many requests as possible. So we did that here in this notebook. You can see we sent one request to Fireworks to our GPT OSS 2 billion parameter that was deployed via serverless, and then slammed it 25 times. But more importantly, moving on to the actual application, the RAG app that we went and built. So I'll just give you a quick showdown of what the application was, since we're very used to RAG. We can actually, a cool way to see it is inside Langsmith, as well as I'll just quickly show you the code. So we've got our models, we've got main.py, and that invokes this graph, and then it's the graph is over here, and we've got our models. So we can see that we've got our chat OpenAI. There's a little bit of fixing to the tool calls to render the JSON nicely when it's passed to the model. We've got the tools themselves. It was just given Tavily for web search, RxIv, and the RAG retriever for the RAG itself. And then there were two agents, a simple agent, which we're quite familiar with, but there was also an agent with helpfulness, and I'll just show you kind of the breakdown between those two just quickly. So our simple agent, which we're quite familiar with, would receive the query and then either call tools or not, and it had the tools available that you can see here. So you've got Tavily for web search, RxV retrieval information for RAG, which we've seen a lot of times. But then there was also a helpfulness one, and this one would actually look at the responses from retrieving and the answer was generating, and decide whether or not to continue based on the final response. And if it found that response was not actually helpful, well, then it would call the agent again. There was a stop limit on this so that it didn't go overboard, but nevertheless, an enhancement to the simple agent, and you can actually see that here. So you've got, this is Langsmith, sorry, and you can see we've got our agent with helpfulness going in a loop and deciding when to end, and then just our simple agent that we're quite used to, where start agent decides to call action in a loop, whether or not that happens, and then ending it finally. So the main activity itself was actually evaluating the fireworks pipeline against an equivalent OpenAI, where we used the GPT 4.1 mini in a pipeline using RAG-S. I actually looked at all 5 metrics. I'll show you the kind of final, well, we've got our evaluation workbook here to look at the numbers, but I'll just give you the results in a nice and easy to read format. So we looked at faithfulness, answer relevancy, context precision, context recall, and answer correctness. We've got we used 8 questions, and we've got a summary of that there with what we thought was what was the winner in that for that metric, and then a breakdown per question. I think the most interesting finding is faithfulness, where OpenAI actually scored 0.731, whereas Fireworks scores 0.434, and you can see that there. And then context recall was essentially identical, which kind of tells us that the embedding models are comparable for retrieval, and the quality gap is entirely in the generation step, not the actual retrieval step. The answer correctness was also interesting. Fireworks came out marginally on top, which kind of and then looking at the context numbers, it kind of shows us that even when it does go off context, it's still directionally accurate, and it's a very capable model. And then we also looked at token usage. So that was kind of on par with maybe OpenAI using a little less. And I think a key takeaway for me is that retrieval quality was equivalent between the 2 providers. The embedding model choice didn't matter as much. The difference is entirely in how well the generation model respects that retrieved context. In this experiment, OpenAI is more disciplined about staying grounded, which matters a lot in production RAG, whereas Fireworks is a pretty solid, cheaper alternative if you kind of put the effort in to tune the prompt and reinforce context-only answer. So yeah, maybe one other cool thing just to show off here was also the tracing from running it. So we've got our tracing from running this entire session, which was also pretty cool to see. But all in all, thanks for listening, and hope you found something useful.